Hi, fifth graders. It's Mrs. Farrell here. I hope everyone is doing well at home. I thought that while we were all home, it might be fun to do some daily number talks via video. So what I'm going to do is go ahead and put a problem up on my little makeshift classroom here today. And you guys can take some time to think it through. I'll go ahead and share my strategy that I would use. You see if it's something similar to what you would do. Remember, a lot of the benefit in doing these number talks is certainly hearing about different strategies. So even though you can't hear a lot of different classmates sharing their strategies, maybe take a look at it and see if you could solve it in a different way other than the first way you thought of. So I'm going to go ahead and put it up. Give it. You can go ahead and pause the video if you want to have some think time, and then maybe down the road we can do a Google Hangout where some of you, if you're interested, could video in to share what your thinking would be, and we can hear from all of you. So anyways, here's your problem. I know this really isn't what you guys are probably working on right now at all, but I figured might as well just get our brains flowing, get some mental math underway. So I'm going to start off just kind of basic today with the problem 345 times 8. So again, you can go ahead and pause it if you want to give it some think time. Otherwise, I'll go ahead and share with you what I would do to solve this problem. So if I was looking at this problem, I would really rather not solve it the way it is currently. I'd rather break up 345 into 300 plus 40 plus 5 and deal with it in chunks. So I might start with 300 times 8. When I multiply 300 times 8, I get 2,400. When I multiply 40 times 8, I get a product of 320. And when I multiply 5 times 8, that equals 40. So now I just need to go through and add up all of my products. So my third grader, Patrick, is helping me out a little bit here. Do you want to explain how you might add those all together?
Yeah. So first, you don't really have to pay attention to the 2 in the 2,000. You just do 400 plus 320 is 720. And then 720 plus 40 is 760.
Okay.
So really the answer is 2,760.
Okay. All right. So think about how you might solve that at home, fifth graders. And as we keep going with this, I'm going to throw in some fraction, decimal, percentage, number talks at some point as well. But I figured we'll just go ahead and get started with this today. So have a great day. Talk to you later. Bye.
What we're going to do in this video is refresh our understanding of place value, but we're going to dig a little bit deeper and think about place value in the context of decimals. So just as a refresher, if I had the number 973, this should be review for you. We already know that this rightmost space right over here, this is the ones place. And if we move one space to the left of that, this is the tens place. Notice we went from ones to tens. Tens are 10 times as much as ones. And then we move one space to the left of that, we multiply by tens again, we get to the hundreds space. And so this 9 doesn't just represent 9, it represents 900. Or we could write that as 900. Similarly, the 7 doesn't just represent 7, it represents 7 tens, or 70. This 3 represents 3 ones, so it actually does represent 3. But as I promised, we're now going to extend our understanding. And what we do is we put a decimal here, which you've probably seen before, at the right. And the reason why we even need a decimal is to really tell us where our ones place is. We say, oh, okay, if we go right to the left of the decimal, that's going to be our one space. Because once we start introducing decimals, we can introduce as many spaces as we want to the right of the decimal. And so let's think about those a little bit. If when we went from hundreds to tens, notice, we divided by 10. When we go from tens to ones, notice you divide by 10. So what do you think this place over here is going to be called? Well, what happens if you take 1 divided by 10? Well, then you get a tenth. So, as you might imagine, this is the tenths place. And then if you were to go one place to the right of that, what would this place be? Well, it would be tenths divided by 10, or 1/10 of a tenth. So this would be a hundredths place. And then if you were to go one space to the right, and we could keep doing this forever, but if we were to go one space to the right of that, what would it be? Well, a hundredth divided by 10, or 1/10 of a hundredth, is a thousandth space. And so, for example, if I were to extend this number, instead of it just being 973, if I were to write 973.526, what do these numbers, these digits represent? This 5 doesn't just represent 5, it represents 5/10. Or another way of writing 5/10, you could write it like this, 0.5. You just have a 5 in the tenths place. Or you could write it as 5/10. This 2, and I think you get where this is going, this doesn't just represent 2, it represents 2 hundredths. I'm just going to make it very explicit in this video so it's very clear. 2 hundredths. Another way to write that is you just write a 2 in the hundredths place. So we're going 2 spaces to the right of the decimal, or you could write it as 2 over 100, 2 hundredths. And so, for kicks, pause the video. What are all the different ways of representing this 6? Or what does this 6 represent? Well, this is 6 thousandths. 6 thousandths. This thousandths. There you go. I could also write that as 0. Let's see, this is a tenths place, hundredths place, and then in the thousandths place, I have 6. Or I could write this as 6 over 1,000, 6 thousandths. So big picture, place value, we can keep going to the right of the decimal, and we can start representing things that are, I guess you could say, more precise.